Hello YouTube, welcome back at my workbench, and today I'm going to work on this lovely K7S5A mainboard, and specifically I will replace these capacitors with these, and these are the same farad value, 2200 microfarads, but they are basically the best quality I could get with the best ESR rating, and they are rated for 105 degrees and I think 20,000 hours at least. So basically I just got the best ones I could get. And when replacing capacitors, it's always like the important value is the microfarads value. Let me show you one a bit closer. So if the camera would focus, it tried to. Yeah, you can't not really see it right now, but it did flash up for a short amount of time. It might get to it again. Yeah, so what you can read in the upper line is 2200 microfarads, and below that it says 10 V, which means 10 volts, and that's maximum rating, so you can exceed that. On the board here, these are rated for 6.3 volts, and that's just a maximum voltage you can put on them. So you can use higher voltage ratings, that's not a problem at all, but you can't get any lower, of course, because then it might blow up. As you might also be able to tell when I hold it right next to the other, yeah, it's hard to see. Maybe if I take it like this, yeah, you can see they are quite a bit taller, which is not a problem in this case at all, because my cooler, it will not interfere with the cooler. That's the important part. But other than that, you can exchange them. You can use higher voltage ratings, higher temperature ratings, or anything. But before I can replace the capacitors, I'll have to remove the CPU heatsink because it gets in the way. And to do that, I'll have to remove the memory. So that's what I'm gonna do first. So you'll also see me remove heatsink from a socket A mainboard. The socket A platform, or let's first I'll have to remove the memory, and I'm not going to go into detail about the memory right now. I just put that aside somewhere. So these socket A CPUs, as you will see in a moment, they are really delicate in a sense. So what you have to do on most of these, to remove the heatsink, there's this little tab down here, and what you do is you put a screwdriver in there and then push down on it, and at the same time like push outward and down at the same time to unlock the tab from the socket. And unlike most modern CPUs, these are directly locked onto the socket. There we go. And as I said, you have to be really careful when working on a socket A, and you'll see why in just a moment. So here we have the CPU exposed, and just to show you, I'll take it out and get it closer to the camera. So this is an AthlonXP CPU, and what you see here in the middle is the silicon. So there's no heat spreader, nothing protecting it. It's just the silicon die right under the heatsink, and silicon is quite brittle. So if you were to apply a bit of sideward force or basically push it onto one of the corners, then you can very easily just chip off corners, break the die itself, and that will kill the CPU instantly. So you really want to be careful and apply force really straight. So I'll just set the CPU aside here, and what I'm going to do now is I'll put the RAM back in for one reason. Not that we're going to use any RAM while soldering, but that's just for the single one reason that I'll have to turn the board upside down, and of course I can't remove these connectors, and so I want to have the memory on this side to get it more even, so it's easier to work on. Now to the capacitors. As you might be able to see, they have a stripe on one side, and that's designating the negative terminal. And we have to remember that, but in this case it's easy because they're all the same direction and all the stripes point towards the socket, and that's all we gotta remember. I'm also going to grab a brush because there's maybe you can see it, there's quite a lot of dust in between these capacitors and the socket, and I want to clean that out. There we go. Yeah, I want to clean that out because what's going to happen is when I'm soldering on the board to remove the capacitors, it's going to heat up a lot of the board, and yeah, I really don't want to basically bake all this dust onto the board, because I actually intend to either use this board myself or maybe sell it. So I want to get it in the very best shape I can possibly. And you'll see I'm not going to replace all the capacitors on here. I already replaced this one. It's quite obvious. These are this greenish color and this one's black. This was really bulging, like it had a real bulge on the top, and that's always a sign of a dead capacitor. All the others, they look quite fine, so I'm not going to replace these, but the ones here, these are for the core voltage for the CPU, and I'm going to replace them. Also this one, just I'm not sure what it's for. It might be for the chipset, but it's the same value as all the others, so I'm I just ordered one more and going to replace it. And yeah, with that said, let's just get into it. So I turn the board over, locate the solder points on the back. They're here, so you'll not be really able to see all the details, but you'll see the general process. What I'm going to try first, I don't have much hope, but I'm going to try this solder wick to remove the solder. So get my soldering iron and I'm just gonna try to remove the solder with this, but as I said, I don't have much hope for this process, because the problem is these mainboards, there's a whole lot of just copper planes on there, and you don't get it hot enough to really get the solder flowing out, especially on the negative terminals. The positive you can sometimes get to flow, but especially the negative, the ground is almost always a plane that goes through the whole mainboard, and it's, yeah, I can already tell this is not going to work at all. So I'm going to use another technique that I know, and I've showed in another video. So what I'm going to do is I'll take the board upright. Let me just adjust the camera a bit so you can see it. So I put the board upright, grab a capacitor on one side, so I basically hold the board like this, and on the other side I'm going to put the heat directly on one of the soldering joints. Let's start up here, and now I'm heating up one of the pins and push the capacitor in one direction, and once this one solder joint melts, there we go, it pulled out the leg a bit in that direction, and now I'm doing the same on the other side, and just basically go back and forth and remove it. And I'll just go ahead and pull out all of them, and after that I'm going to try again to maybe get the solder out of there, because as long as the capacitor is still there, like these legs, they are they look silver on the outside, but it's really copper inside. So there's basically a copper wire that's, it's not only conducting electricity very well, but also heat. That's why copper is used for heat sinks a lot. So that's something to keep in mind when you're soldering, that where your heat is actually going, and if you have a whole lot of copper on connected to a solder joint, then that's gonna basically suck away a lot of heat, and yeah, you have to keep that in mind. So if you have, like in this case in a mainboard, you have a ground plane that's going to be basically almost the size of the mainboard itself, that acts as a heat sink for your solder joint, and it's going to suck away a lot of heat. So it can take a very long time to heat up a solder joint, and you don't want to heat it for a long time, because that's going to kill your part that you're trying to solder, or it can also damage the mainboard itself, because these mainboards, they're made either of fiberglass or what's called, I don't know if there's a special name for it in English. We call it Hartpapier, hard paper. Basically paper with epoxy, and stuff like that. It doesn't like to be heated, and over time it will degrade. And yeah, so you really want to keep the time for soldering down to maybe a few seconds. And yeah, it also depends on the power of your soldering iron, because of course if your soldering iron is heating with like 40 watts or 60 watts, then it's going to get the temperature much faster, which is better. And but if you have a really low power soldering iron, which is most of the time very good for soldering small stuff, then it's going to take forever, and by the time you melt the solder, you will also have basically melted the PCB itself. So yeah, that's also something to keep in mind. And yeah, I'm just going back and forth, removing all of the capacitors I want to replace. And yeah, pulling them out like this, you just have to be careful that you're not putting too much pressure on it, because as you might be able to tell, pushing on this gives you a lot of leverage, and if you put too much pressure on it, when the solder is not fully melted, what can happen is that you rip a piece of the conductor off of the board, and yeah, that's not actually an instant death. It might still work in a lot of cases, depending on the actual layout and what's connected to this solder joint, but yeah, it's not exactly high quality anymore then. So yeah, and since I'm trying to improve the quality here, I really want to avoid that. I don't know if you can hear it, but there's some construction going on next door, so yeah, but we'll just have to deal with the noise. There's really nothing I can do about that. Cut that one out. Get out that one as well. And if you find that it's really hard to get the solder to melt, it helps to put a bit of fresh solder on your tip, because that increases the conductivity, and helps the heat get to the solder joint much faster and easier. So there we go. All the capacitors removed. And there's even some dust under there, and I'm going to just brush that off as well. There's even dust inside the socket here. So now I'm going to try and remove the solder again, because now the copper legs are no longer there, and as long as these legs are stuck in the board, basically all the metal of the capacitor acts as a heatsink as well. So now that we removed that, going to take this solder pump. You can get them for like $1. They're really cheap. And how it works is it's spring-loaded inside. You just push down the button, and then it has this release, and when you push it, it snaps out and creates a vacuum. And so the idea is to try to suck out the solder from the hole. So I heat it up from the back and then put the pump on the joint and push, and that seems to have worked. Yeah, as I said in a previous video, where someone really struggled with getting these holes free for replacing capacitors, it really helps to get out the capacitor first and then remove the solder. That makes it just a lot easier, because you just remove all this thermal capacity. Yeah, that's kind of working. Not perfect, but yeah, that looks good. So I'll just go ahead and do this for all of these. Yeah, I'm going to have to do some, let's call it after work on these, but right now I just want to get as much solder as possible out of there. And I'll do some cleanup later. Because once all the solder is out of there, it's going to be rather easy, and I might even try again using the solder wick to remove the remaining stuff that's stuck on the solder joints there. And this is a bit tricky, holding the board like this, but it's just practice. If you've done this once or twice, then it becomes rather easy. What I notice right now is that usually that was not usually the case, but here you have these holes right next to the socket, like it is in modern boards, and I might look if it may be possible to fit a modern heatsink on here if the position of the holes is in any way similar to like a socket AM2 or 3 or AM4. I think they're almost the same. And if they're similar enough, I might be able to put a modern heatsink on here. And these, the CPUs on this platform, the AthlonXPs, they did run really hot, especially because they were really good overclockers. You could push them really far, but they produced massive amounts of heat. And since they didn't come with integrated heat spreaders, cooling these was a bit tricky. So I would really like to get as good as cooling as possible. It looks okay-ish. I'm just holding it up against the light, and all but one seem to be free, and that's this one back here. Oh yeah. Oh, wait a minute. Yeah, I should rework the outer side of these. That looks a bit better. And it's like you don't have to remove all of the solder. It's just you just want to remove enough of it so that you can stick in the new part. If there's a bit left, it's not really a problem, as long as there's enough room to fit through the leg of the new capacitor. Okay, I think we won't get much further with the pump like that. So what I'm going to do now is I have this flux pen, and it's basically like a pen, but it's filled with liquid flux, and I'll put a little bit of that onto the solder joints here, and also on this solder wick. And what that does is just it helps the copper flow better. Yeah, but that doesn't help at all, because with these with this stuff you have the same problem, because it's of copper and it pulls a lot of heat away from the solder joints. So what I'm going to do instead is just put flux on there and heat up the hole. And usually because there's this hole, and when you heat it up, the solder will stick to the sides and give us, with any luck, that will give us enough room to push through our leg. But it seems that there's a lot of solder left here, so what I'll do now is put flux on all of these. And by the way, if you have the ability, you should put a fan next to you to suck away the fumes that come off of this stuff, because it's acid, and you should really try not to breathe acid steam. That's not something desirable. At least not if you care for your health, which I think most people will. Okay, that looks better. So let's repeat that. Also, because this is acid flux, I will clean off the board afterwards. Because you really don't want to have this acid stuff hanging around on the board, because over time it's going to eat away the on the board basically, and yeah, that would be kind of counterproductive if we put new expensive high quality capacitors in there and then let the flux eat away the board, and within a few weeks it's going to be dead anyway. Yeah, that helped a bit. There's still one that's blocked, and that's the ground here. As you can see, I'm checking a lot, and that's something that should be always advised when working on any electronics. Basically, always double and triple check what you're doing, and check again, and better to check 5 times than to mess up once, because especially with vintage stuff like this is, it's from the early 2000s, so this thing is almost 20 years old now, and they don't make it anymore. So if you actually kill it, there's no way to replace the board itself. And this specific model, the K7S5A, it was a very popular one. It was basically a budget board, and originally it did not support the highest AthlonXP models with the Barton core. It only supported the thoroughbred versions, but there's a modded BIOS, which of course I installed here, that adds support for the Barton cores. Yeah, this is a stubborn one. It almost seems like there's some kind of debris stuck in there. So I'll just grab a needle and try to poke in it. Okay, that's just fine. And that's something else you can do, but you need to be really careful because when using a needle like that, you can easily break the contacts. So, but sometimes it can be hard to tell if the hole is open. When you look at it and you see light, it's sometimes hard to tell if it's actually light coming through or just some reflection. So it can help to just poke a needle in there and then you see if the hole is open or not. And as I said before, they don't need to be 100% free of solder. I just remove the stuff that's stuck on these solder joints here. There's a little bit here, and that's just because if there's tiny bits of solder left on there, then what can happen is that this isn't advised at all, like working with highly acidic and poisonous stuff and drinking coffee at the same time, so don't do it. But yeah, what I wanted to say is if there's like tiny bits of solder stuck on the sides of these, it's better to remove it because it might break off any time in the future and then fall down, because your board will be mounted like this in a tower case. If there's some tiny bit of solder that breaks off any time in the future, it will fall down and maybe land on anything else and short something out. So yeah, you want to really make sure that all of this remaining solder is removed. And then yeah, let's just go over it with the brush once again. And cleaning is always a good idea. So now let's grab our new capacitors. And what you really have to take care about is that the distance between the legs, which is in German it's called Rastermaß. Don't know the English word for it, but there's different ones and you have to get the right ones or else it won't fit in. But now we can just push that in. And it seems like the height is really matching. So what I'm going to do is I'm going to I'll use a little trick, and that's when you push in the legs and you just bend them a little bit outward so they can't fall out. And do that with all of them. It doesn't matter if they're hanging down in a bit of a wonky position or if they're a bit wobbly. That's not a concern right now. It's just important that they don't fall out. So I'll just put all of them in, bend the legs out a little bit to keep them roughly in place. It seems that there's some solder still stuck in here, and I'm not going to force it in. Instead, what I'm gonna do is I try sucking out this very spot again, because as I said before, if I were to just force it through, I might break the contact at that spot. So I'm not going to take that risk, but instead, and the one right next to it doesn't look very good either. There's a little bit of solder stuck on there. That's a bit of a stubborn one. Let's just try if it works now. There we go. And yeah, as you can see, this looks not tidy at all, but it's not going to stay like that. And there's another stubborn one. So let's grab the needle and try to poke it through. No, that's not gonna work. So get out the pump again. Yeah, as you can see, it's rather tricky, and now I have to pull this one out again because I need the room to work at. So that's another reason why it's really helpful to just remove the capacitors before you even try to remove the solder, because it just gives you more room to work, and you can actually see what's going on. Like right now, I'm watching the front of the solder joint, because on the back side I can feel that it's already molten, but here on the front it's still solid. So I'm just watching it and try to see when it's melting. That didn't work. And of course, every time I activate this sucker, it pulls a lot of air through, which has a cooling effect, so that will pull away the heat, and I need to let it heat up again. But I think that should be enough. Yeah, there we go. Now it goes in, and this one goes in as well. Just bend these legs a little bit. one down here. So, and what I'm going to do now is on each of these, I'm just going to solder one of the points. Let's use a different type of solder. I always have different types of solder. Like this is 1 millimeter. It's going to focus. Well, not really. Yeah, this is 1 millimeter. I also this is also 1 millimeter. Then I have this 0.5 millimeter and 0.8. I'm going to use the 0.5 here. And now I'm going to just solder one side of each. I should really change the solder tip. That's one good thing when you have a soldering station as opposed to just a soldering iron. Especially if it's a good branded one, then you can exchange the solder tips, and there's a lot of different ones. And this one is a quite large one, as you can see. Which is good for jobs where you need a lot of heat but not so much precision, like desoldering stuff. That's something where you're desoldering, so you don't care for the part you're removing so much. And what I'm going to put in there now is this one. It's really pointy, which will transfer less heat, but will allow me to work more precisely on the spot. And if you get some cheap no-name soldering iron, you might have a hard time finding different tips for it. Of course, now I'll have to wait for it to heat up. That's another thing, like the heating up time for cheap one can be really long. And in this case I also have another soldering tip which is really long and pointy, and I use that for really high precision stuff, like soldering wires to SMD chips or stuff like that. And they aren't really cheap. Like one of these tips is like $5 or $6, but I think it's worth it to get quality equipment. I actually got this soldering station for free. It was a present, and yeah, all I have to do is get new tips, like maybe once a year or something, because they do get used up over time. Basically they almost disintegrate. Yeah, but that's just something that happens and you can't avoid that. And I'm not even caring too much right now if the joint is really perfect. It just has to be a bit stable mechanically. And now what I'm gonna do is go over each of these again, heat up the solder joint on the back, and push down the capacitor in position. So that it sits flush on the board. And I'm going to do this for each one separately. And this is a bit a thing of feeling, like when you push on them you can feel them slipping the last bit in place. This will make sure that they all sit flush on the board and straight up. I mean, they're not going to be straight right now, but now I have one of the legs at least sitting straight in there. And just to make life a bit easier for me, I'm going to cut off most of these legs. This is not the final length. I'm leaving a bit more than required. It's just for me, so I can easily tell which are already soldered, and also they don't get in the way. And now I'm pulling the other ones straight again. And this is just because it wouldn't really make a big of a difference, but should someone have to replace this in the future again, if they're bent outward and they want to use the same trick I did, like wiggling them out, having them bent outward would give a really hard time with that. So yeah. So now we're going to solder in the other side of each, and again I'll do a final solder, because as it seems this works really nice. So if I see that they're sitting straight, then I'm not gonna bother. So now they're all being nicely held in place on both sides. Now I'm going to do the same thing again as before, just pushing on the capacitor, but this time heating up the other side and pushing down, so to make sure that they sit really straight. There we go. Yeah, that looks much better. Okay, so now they're all sitting. Oh no, not really. This one isn't really straight at all. So I'm looking at it from this side, and that's a downside when you use tall capacitors like these. When they're not straight, it becomes really obvious, and electrically or quality-wise, it doesn't make big of a difference, but it just looks ugly if they're all over the place. And so I'm going to correct them all to sit really straight. There might be a trick to get this really easy, but I will just correct it manually one by one. And I think it's not going to be absolutely perfect. But no one is ever going to see the board from this perspective when it's in use, so it doesn't bother me too much. I just don't want them to be really all over the place. Yeah, I think that's good enough. So, of course, they're going to move a little bit again, because when you push them in like this, you're putting a bit of tension on the solder joints. And then when you heat up one side of it again, that tension gets released, and it's going to move out of place again. But now I'm doing the final correction, and I can already see them moving a bit again. Let's check that. It's still okay. One little trick when you cut stuff like this, like short wires, if you just cut it, maybe you heard that, it flies all over the place. So what I like to do is put my finger on top of it so that the metal piece can't just fly away and maybe make a short somewhere. Because with electronics, what you really don't want is metal pieces flying around. So I either, if it's a long leg, I hold it with my other hand, or if it's a short one, I put a finger on top of it. And these are final. I'm going to leave them like that. just want to make sure that the hole is completely covered in solder and that it's not just partially soldered but really completely. So some of them are a bit what I would call a bit fat, but it'll be fine for this. And as for how long to cut them, basically just look at the other solder joints around there, but the basic idea is they have to be short enough so when you screw it inside the case that they don't touch the back of the case and get shorted out. But yeah, that's it. So new capacitors are in place. These are some of the best capacitors you can get, and I think this board will last for many years to come like that. I might even have a bit more headroom now because these are for the core voltage. What I might do in the future is you can see in here are the MOSFETs that are actually generating the voltage, and someday I might go ahead and stick heatsink on there just to make the voltage delivery more stable for the CPU. There's this one that's out of the just correct that a little. Yeah, there we go. That's just fine. So, but we're not done yet because we need to clean up, and that's an important part. So what I'm going to do is I'll grab Q-tips and what I've seen is there's a bit of, you can tell there's a bit of discoloration there. So I'll take some general window cleaner and just a little bit on the Q-tip here. I'm not using acetone for that because the socket is made of plastic and acetone would probably melt it. Just rubbing off here, and yeah, I can see that it gets cleaned up. Of course, there's now a window cleaner going into the holes of the socket, so I'll have to wait for a while, maybe at least a couple of hours before I put the CPU back in here. But yeah, since I've got it, the CPU out of it and got it accessible like that, why not? I mean, it might take a little extra time, but and it's not going to change anything functionally. It's just that when I take it apart again and look at it, or if I might even sell it and someone else takes it apart, if these are the small things that just make it feel more quality. And a lot of people underestimate that, but cleaning computer parts is really, in some cases it's really important, like for heat sinks or stuff like that. But in general, even though a chip will still work if it's covered in dust and dirt, it just doesn't give it a feeling of quality, and so it's always a good thing to spend the extra bit of time. So this took me like maybe a minute or something, or let's say 2 or 3 minutes, but it looks much better, much more clean, and yeah. And you might be able to see, like, this is the original color and this is what it looks like now. So I got a lot of dirt off from there. Oh yeah, there's also some stuck inside here. So that's it. Yeah, so the replacement is basically done, but while I'm in the process of cleaning up, I'm going to... Now we have to mount the heatsink again, of course, but yeah, whatever. I'll mount the heatsink so you can see that as well. First I'm going to place the CPU in again, and on these CPUs, if you look on the back here, you can see there's a golden triangle up here, and also in this corner there's no pin. And if you look at the pins down here and down here, they go all the way to the corner, but on this and this side the corner pin is basically missing, and on the socket here, yeah, it doesn't really show, and the light is not the best, but yeah, you'll have basically two sides where the pins in the corner are there, and on the other side the corner pins are missing, and that's how you know which way to put it in. And you just open this lever, drop it in, it should just fall in. If it's not falling straight in, then there's a bent pin. Push the lever back, and that's it. The CPU mounted. Now what I'm gonna do is just use this Q-tip to remove the most of the old thermal paste. And whenever you take a heatsink off of any CPU or GPU, you don't just put it back on. That's not what you do. You always remove any remaining thermal compound and put new thermal compound on, always. And now I'm going to use my trusty nail polish remover acetone compound stuff, and use that to really remove any remaining not just thermal compound, but also there might be like oil that you have on your hand when you touch it or stuff like that, and all of that could negatively influence the thermal conductivity. Also clean around the CPU die and really clean that up. Don't leave any remaining stuff around here. especially if you find some thermal paste has metal in it, because that gives it a higher conductivity, but that also can short out components like these. And I'll do the same thing here on the heatsink itself. Also, yeah, for this rough stuff, I'll remove it like that, and then put some acetone on it, and rub off the rest of it. And then what I like to do for the heatsink itself, because that has a greater area, and just take a bit of TP and put some nail polish remover on that, and then basically wipe off all of the remaining area here. And we'll only put the CPU here, so that's basically all that matters, but I like to clean a bit more, because why not? And as you can tell, there's a lot of dirt on there, and that's not necessarily a sign of actually dirt, but it's just copper really does oxidize really fast wherever it gets in contact with oxygen. So yeah, you might be able to tell it's really shiny now and cleaned off. You can even see the residue where the CPU sat on there, and the text engraved in the CPU is kind of visible on the underside there. So now that that's all done, I need some fresh thermal compound, which I got up here, and I'll just apply a little bit on here, and there's no need to spread that out. It's going to spread with the pressure of this thing. And now comes the tricky part again. So this is the thing where you have to be really careful with this socket A CPUs, because as I mentioned before, it's really easy to break off the die. So what I'm doing is I'm pushing the clamp all the way up on this side so that it comes out as much as possible on this side. And then I put it on so that it grabs on the socket on one side. And now it sits on the CPU die. So now starts the critical part, where we really have to make sure that it's not going to be pushed diagonally in any way. I put the screwdriver on this clamp, hold the heatsink really straight and push down. This needs a lot of force. There we go. Got that mounted. And a lot of these AthlonXP CPUs died in this process because it's really delicate. So I'll just connect the heatsink again, a fan. And before I go to the final mounting, I'll just take this towel and because I don't know if the camera will pick that up, but yeah, these heat spreaders, they don't look so clean anymore. Because as I mentioned in a previous video, I have these heat spreaders. They were aftermarket heat spreaders that I bought back in the early 2000s when I actually built my own Duron PC back in the days. So these heat spreaders, they are like 20 years old and they deserve to be cleaned a bit. So I just clean them up to make them nice and shiny again. Remove any fingerprints from the silver part up here. And then put the memory back in. And I'm using the towel to push it down, just so that I don't make any new fingerprints in the process. And you can still find aftermarket heatsinks like these on I think AliExpress or maybe eBay. You can get them in all sorts of colors, and if you are someone who is on a budget, because nowadays you can get fancy RAM like the Trident C, or from Corsair there's memories with really fancy heat spreaders on, but they're kind of expensive, and most of the time you can get cheaper memory with the same timings, and I mean there's not so much of a difference because memory quality is all about just the frequency and timing. So if you get a different memory with the same frequency and timing, okay, an expensive kit might give you more headroom for overclocking, but if you buy let's say like a 3200 memory kit and you intend to run it at 3200, then it doesn't make a difference from which brand it is. You just buy it and you just check the timings that it's rated for, and if it doesn't run at the timings that it's rated for, then you just send it back as an RMA, because it has to run at that, no matter if it's cheap or not. But yeah, you can get most of the time you can get cheap memories without any heat spreader for much cheaper with the same frequency and timings, and then just grab a set of these heat spreaders for like 10 bucks and put them on. And the nice thing is, this is DDR1 memory, but let's see, I think I have one here. This board also supports SDRAM, like the non-DDR kind, and as you can see, this is DDR. It has this notch here. SDRAM has 2 notches, and the later iterations, like this is DDR only, just DDR, and then there was DDR2 and DDR3, and now we're at DDR4 memory. But they're physically only the only physical difference is the notches they have, and that's to make sure that you can't fit a wrong one. But physically, like, the size is all the same. So these heatsinks I bought back in the day for my DDR1 memory, but they will still fit on a modern DDR4 memory if I want to. So if you buy these, there's no reason why you can't just take them off, put them on another set of memory and use them basically forever. You might have to replace the thermal pads after a while, but other than that, as I said, I've used these for 20 years, put them on like 10 different memory kits, and they just do what they're doing. Yeah, so that's it. Board is recapped, everything is back in place. I'm not gonna do a functional test right now because I'm really pretty sure that it's not going to explode or anything. Yeah, I'll just call it a day and yeah, save the testing for another day, because this board, and together with the the graphics card that I put new heat sinks on, all of that is going to go together and make a really nice Windows XP retro gaming machine. But I'll save that for another day, like doing assembly and doing some benchmarks and stuff. But that will be for another day. So that means we're done, and goodbye.